Hey everyone, in this tutorial I'm going to talk about how to create tornado using SOP solver with the help of velocities and noises. And there are lots of tips and tricks I'm going to talk about. So without further ado, let's get started. Let's take a line. To define shape of our tornado, we will use polywire. And here we need tipper at the bottom. So for that we will use resample. And it has one attribute called curve view, which is from 0 to 1. So let's use that here. To use that here, we need to add. And here I want to increase. Let's lock our view. And I want to increase division size. Cool. So here I need particles first. Let's use point from volume. And everything looks uniform, so here I need some jitter scale. Yeah, that's all. And here we need a motion. For motion we will use transform. We will use $f. So you can see here it's rotating, and you can increase this here also. And after that you can add mountain also on this. And if you add animated noise, it will look more cool now. So this is how you can create tornado, and you can increase speed also. So hope you like, and see you next time. I hope you're still there. Okay, so we don't need all of this. It was that easy, but let's understand this. We need velocity in this motion. So how we can achieve that? And for that we will use concept called cross product. And let's just check how we can use that. So we will use warp. Let's just check our normals. So what I will do over here, I have this vector and I will use up vector. And what cross product will do, cross product will create this axis. So for every point it will do that. Let's just check over here. So here I will use cross product, and you can see here by default it has up vector. So all I have to do is connect this into first input, and let's just check. Yeah, that's all we want, and it's working fine. And I want this in velocity. So let's just check our velocity here. And I will transfer that velocity here. Attribute transfer from here to there. So let's just transfer velocity. That's all we want now. Distance 0. How we can use velocity to drive that simulation? Here I will use point triangle to do that, just for quick demo. So I have position. I wish to add that velocity on each frame. I'll multiply it. So let's just check, and it's too much, I guess. Let's just reduce it by 10. Right, so you can see it's working, but this is not the right way. All we need is a brain in the sense that we need to remember previous value to add current value. And how we can do that? For that we will use SOP solver. And let me just explain what is SOP solver quickly. Right, so I have this character, and Joey wants to save $5 each day. So how we can do that calculation? And on 5th day we have to remember, so what was total saving on 4th day, right? So that's how we can add $5 on 5th day. So to do that calculation, here let me just create $, and at the moment he has $0. So how we can use SOP solver to do that? So let's just use SOP solver, and let's go inside. And it has previous frame, right? So here I have to just connect this over here. Add $. I have that attribute dollars, plus I want to save $5 each day, and make sure you use out node, so it always stay on that frame. Now just let's flip this screen, and we need geometry spreadsheet to check that. Yes, so here, okay, we need $. It's okay. So now you can see here that it was 0. Now it's adding that value. So if I go to next frame, it will add, right? So it remembers what was the calculation on 11th frame. It will add $5 on 12th frame. So that's how we can use, and it's very useful in most cases. And let me just show you how we can use this in our example. Let's rename this let's use soft solver to do that. And here I will use point warp, so it's easy to understand. Cool. So let's add that velocity. Right, so you can see it's too much right now. Let's reduce it. 0.1. Yeah, this much is fine. So let's just check. Cool, it's working. So it's giving the similar output which we were getting. Let's just pin this. Why it's happening this way, and let's just understand that. For that we have to check our velocity and what exactly happening to our velocity, why it's going outside. Till here it's fine. When it's adding each frame, you can see it's so nothing wrong, it's just following velocity. So we have to correct our velocity, and so how we can do that? So here when it's changing its velocity, we have to reset its velocity. So for that again we will use attribute transfer to do that. Input 2, and let's just set v. Let's check now. It's working, right? Again it's expanding, so for that we have to tweak our velocity and just check how we can tweak our velocity. And I think it's easy way to visualize these trails. Where is it? Here. So you can see here it's still pointed outward a little bit. So how we can invert it slightly, and for that again we will create one vector to blend it. So all we need is outward vector, and let's just check how we can do that. So all I need is here, right? So currently it's correct, but if you can check here that it's pointing downward also. I have to remove that y-axis, and to remove that y-axis I will just multiply. I want x, not 0. Here you can see it, how it's changed now, and let's just transfer that here. Now we have to blend this to value. How we can do that? So I will use mix. I want this. So you can see here that if I blend this, right, so it's still pointing outward, so I have to invert this, and for that I will use multiply and minus. Let me just clean this a bit so it's easy to understand. Cool. So let's check now. You can see it's pointing inside, and that's all we want. So let's use 0.9. Right, so it's not expanding. Yeah, it's changing that position, but it's not expanding, and here I don't want that much. Now we have that tornado motion, and how we can make this interesting. So if you notice here that every point is moving on same speed, so let's add random speed on each number. Let's just check how we can do that, and for that I will use turbulent noise. Let's just check first over here that what exactly. Let's use feet. And we will multiply this here. Let's just check what we are getting over here. Now you can pin, and so you can see here now that everything is static. So here I want some motion in those points. It shouldn't be completely static. So you can see here that some points are moving slow and some points are moving faster. Let's just increase here. It's still like motion is, and I wish to use offset this also, you know, that it's, if it's like every point should get chance. So if it's moving noise, then we will get everything covered. And I think we can stay inside as it's pinned on the outside. And in fact, we can make this more interesting by adding a noise. And now we have to keep our network clear, that as we are going to use more. You can see here that I am using position multiple times, so for that I will just create null to keep this clean, right? And it is always like tough to keep our WAP network clear, but let's just try it over here and here. So here we can add noise, and there are always various noise. If you have noticed over here that when I am offsetting it, so it's, you can say something is going upward, and that's fine for this motion. It won't be good for our noise, and for that I need some random motion in the noise, and best way to use 4D noise. So for 4D noise we use anti-aliased noise, and it has the 4D input. And what is 4D input? So it's vector to vector float. So we need position over here, and in here I need some motion. So let me just promote it. Cool, right? So let's just add that, and I want some motion, so I'll use $T. So let's just check. Oops, it's too much. And let's use 3D noise, reduce it. We are getting some cool effect, but we are losing that our main effect. So let's just reduce even more, right? And let's just increase frequency, so it's too big at the moment, right? And in fact we should increase our speed also by 0.1, and let's just check output, right? So now, like, you can see here that we are getting interesting shapes and everything here. So here we have not used any pop network or something. It's everything created using our vector and some simple mathematics. And yeah, if you spend more time on this, and you can take this to next level, and also you can use same concept in DOP also, where you will get live pop forces, and to enhance this even more further. And I also, like, it's not limited to tornado only, and here I have just created some other thing also, like you can create some interesting effect like this also. It's using the same concept. Hope you like it, and see you next time.